Alright, so this is going to be the extra practice versus displacement worksheet on Google Classrooms. Alright, so again, it's labeled under distance versus displacement, okay? Under kinematics. So, number one, a jogger runs 6 km east before pausing to take a break. She then jogs 3 km further east to meet up with her friends at a park. So, what does it do? Kind of want to draw a diagram. Why isn't? Oh, it's because I'm on a racer. Give me a second. Alright, so let's get started with one. Alright. So, let's start with 0. Again, we start from our initial point and we kind of go this way, 6 km, right? So this is 6 km to the east. And then we travel 3 more kilometers to the east. Alright, so now what is her total distance traveled? Well, her total distance traveled is 6 plus 3. So 6 plus 3 is 9 km. I ignored the units here. Please do not do that. But for now, we're just doing this. So 6 km. Now, distance is a scalar value, is a scalar quantity, which means that it does not have a direction. It just has a number and a unit, and that's it. Okay? Now, what was her displacement? Let me just write this. This is A, answered A. What was her displacement? Well, she ends up here. This is her final position over here, right? So how far apart is her final position from 0? How far apart is point A from point B? Well, it's going to be 9 kilometers, right? But we're still not done here because, again, we need a direction. So there's east, there's north, there's west, there's south. All right. And so we need to know which direction this is the endpoint from from our final position from initial. And we know that our final position is east of our initial point. All right? Now, let's do C. Oh, wait, there is no C. Let's do 2. Car travels along a straight road. Again, we kind of want to draw it over here. Travel 100 meters to the east. I'm gonna travel 50 meters back west. All right. And so A would be, what was the car's total distance traveled? Well, it's 100 plus 50, which is gonna be 150 meters. Now what is B? Where does she end up? Well, we started here, which is a 0 point, and we ended up over here because that's where our final position is. We went this way, and then we went this way. And so this position right here is 50. So how far apart are these two? Well, they're 50 meters apart. And our direction? Well, this point right here, our final position, is east of our initial starting position. And so we can write 50 meters east. All right, let's erase all this. All right, let's go to number 3. Number 3. So number 3 says a man runs 2 km north. So we're going to draw our starting point. 0, label at 0. I go up 2 km. This is north. And then I go down. I go down 3k. What is going on with my writing utensil? 3 km. Hold on. Let me redraw this. So we go down 3 km. So now this is my final position. This is my final position. All right. So how far apart is my final position from my initial, right? So my displacement is going to be 1 km south. Because again, the final position is south of our initial position right here, right? Now, I neglected to do total distance traveled because I assumed that that would be fine. This is going to be 5 km because all I'm doing is adding 2 plus 3, and I get 5. Okay? Number 4. In the drill during basketball practice, a player runs the length of the 30-meter court 3 times 30-meter court and back. So basically, if we were to draw this diagram, this would be my starting, okay? Guy runs this way, and the guy runs this way back. And that's one full lap. That's 30-meter court and back. The player does this 3 times, so let's do this one more time. This is the second time now. And this is the end, finishing his lap. The third time, and then finishing the third lap. So where do I end up? I end up over here. This is my final position. Okay. So how far apart is my final position from my initial starting position? Initial. I'm at the same point. I'm back at the same point. It's 0. Right? It's 0. And that's my answer. If I were to ask you, well, what is my total distance traveled? Well, it'll be 30 plus 30, because again, 60 meters, because he goes to the court and back. Another 60, and another 60. So that's 180. So my total distance that I traveled would be 180. But my displacement would be 0. Okay, my displacement would be 0. Let's move on to 5. A baseball player runs 27.4 meters from the batter's box to first base. Okay, 27.4 from batter's box. Let's just switch batter's box for home base. All right, so let's say your home base is this. All right. Let's say this is first base. Okay, and so you travel here. That's 0. Go all the way over here, and that takes you 27.4 meters. Then what? Then it says here I overrun first base by 3 meters. Go 3 meters this way. And then it says, and then returns to first base. So I travel 3 meters away, and I take another 3 meters going back to my first base. And so my first base is going to be my final position. All right, so this is going to be my final position. Well, what's my total distance now? The distance that I traveled, it has to be 33.4 meters. Because went to first base, I went 3 more meters, and then I went another 3 meters back to first base. So 27.4 plus 3 plus 3 is going to be 33.4. Displacement. What is my displacement? What was my final position? Here, over here, final position, minus 0. It's going to be 27.4 meters. Normally there's a direction here, so let's just say it's northeast. All right. So the question asks you, Compared to the total distance traveled by the player, the magnitude of the player's total displacement from the batter's box is what? Right? It wants you to compare displacement to distance. How does displacement compare to distance? And it only cares about the magnitude. Once you see the word magnitude, you kind of instinctively know, well, they just want the scalar quantity. They just want the number. So how does displacement compare to distance? Well, this 27.4 is 6 meters shorter than your distance. So is B, all right? Number six. Number six is something I want you to figure out. That's something you can figure out easily. Number seven. So let's kind of figure this out. I go 4 blocks this way, 3 blocks this way, 4 blocks to my school. If I were to make a displacement value, that's well, okay. It would kind of look like this. Right? It would kind of look like that. Now, this is my final. This is my 0. This is 4. This is 3. This is 4. So how would I solve this? How would I solve this? Is displacement and displacement, distance and displacement equal, less, greater, the same? What is it? So instantly right away, you can probably calculate this. I would cut 3 in half, and I would use the Pythagorean theorem to kind of solve for this side. Right, if we were to cut 3 in half, it'd be 1.5. So each of these sides, each of these smaller sides is 1.5. So we'll do 4 squared plus 1.5 squared is equal to c squared. So 16 plus 1.5 squared. Would not know. Let's just say, let's actually use a calculator. Where is my calculator? Let us calculate it. Is 2.25. So c squared. So 16 plus 2.25. 18.25. Wow, yeah, I actually went to my calculator for that. That's when you know it's embarrassing. All right. Now, square root of, want to square root both sides. Square root of 18.5, 0.25. Hold on. And we get 4.27 is equal to C. 4.27, 4.27. All right. And so we know that, well, if our sides of our hypotenuse is 4.27 each, our displacement is going to be around 8.5. I'm just going to write that, 8.5 meters. And our total distance is 4, 3, 4, 11 meters. All right. So which one is greater? You do the math. The magnitude of her displacement from home to school is less than the distance. Less. 8. So 8 now. Runner travels around the circular track. So let's say she starts all the way over here, runs around the track. Alright, and that's 8 meters long, so let's say that's 0. So if she runs around the lap, she kind of ends up back here. So she runs 3 laps, there's a second lap, and a third lap. So what is her total distance traveled? Well, each lap is 30 meters long, runs 3 laps. So 30 times 3 is 90 meters, or total distance traveled is 90 meters. But if she ends up back up at the same location, well, her final position is 0. Her starting position is 0. Her displacement is going to be 0 meters. This is usually enough to satisfy a direction. 0 is 0. We don't need direction for this. 9, is it possible for your distance of an object to be greater than the displacement of an object? Uh, we're gonna say, well, this for an object greater than the displacement of the object. So let's say we take point A and we kind of go to point B, right? And so we're gonna call that, let's say, 5 meters. If I just go straight from point A to point B, well, that's the simplest you can get, right? It's point A to point B, and that's going to be my displacement. So my displacement is going to be 5 meters. And my distance? Well, it's also going to be 5 meters. It's going to be the same exact thing. If I try to make it shorter, well, now I want to know point A to this point, point C. If let's say this is 3 meters, well, that just means my displacement there from point A to point C was 3 meters. And my distance, if I were just travel from point A to point C, that would also be 3 meters. So your distance, your displacement can never be, well, your distance can be greater than your displacement, right? Let's say instead of just going from point A to point B, I kind of just took a detour, went this way, right? And we can clearly see that this takes longer than 5 meters. So yes, it is possible for the distance of an object to be greater than the displacement of the object. But number 10, on the other hand, is it possible for the displacement of an object to be greater than the distance? From what we're seeing here, definitely not. Because if we make this any shorter, our distance ends up being equal to displacement. No matter what we do, if we go from point A to point B, well, that's my displacement. This is also my distance traveled. We can't get any shorter than that. It has to be either the same or less. Your displacement has to be the same or less than your distance. Okay? Any problems? Just ask in class.